Hello guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, that is the BYJU'S exam prep. So yes guys, we are live into the session to discuss of the 11 most expected questions. The 11 most expected questions on the DTFT. The 11 most expected questions on the DTFT. 11 most expected questions on the DTFT. Yes guys, the session is live. You can quickly update your friends. You can quickly share the session so that students join on the session quickly and we can hence start the session. Okay guys. Okay. Chalo, so let's get moving ahead. The questions on the DTFT. The expected questions on the DTFT. This is a brief intro as always about me. This is your mentor and educator Rakesh. I have secured All India rank 9th in the GATE examination. Right, I've completed my masters from Indian Institute of Science, Bangalore, and I've trained more than 50,000 students in my 12 plus years of industry teaching experience, and these are my major area of expertise that I commonly deal with. Okay guys, a quick important update for you that the coming Sunday, that is 17th July, on the BYJU'S exam prep app, yes, this is not on the YouTube, it's on the app, on our app, right, a free mega workshop, this time to be taken by me, right, 12:30 p.m. live on the Sunday on the app, where I'll discuss the 7 golden rules to secure single digit rank in the GATE. 7 golden rules to secure single digit GATE in the GATE examination. Single digit rank in the GATE examination. So guys, question number 1 for today. Ready, jumping for you. Okay, so different aspects of DTFT will be covered. So this question number 1 itself has 5 different parts. For the signal shown in the figure, find the following quantities without calculating the DTFT. So this is a property based questions, and most of the questions guys of DTFT, will be without property, will be with property, I mean to say. Not directly calculating DTFT, but utilizing the property somehow, although there can be some direct questions also that we are also going to see. But first let's see this case, right? What is x0, x pi, integral, and let us revise all of these properties. So basically guys, what is the DTFT formula? If you just recall the basic DTFT formula, right, we write down the basic DTFT as x omega given by the formula of summation of xn e raised to the power minus j omega n from n equal to minus infinity to infinity. As I just told you, putting z equal to e power j omega in the z transform formula, we get the DTFT formula. And similarly, what should be the IDTFT formula? What should be the IDTFT formula? Xn is given by 1 upon 2 pi integral over any one time period x omega e raised to the power j omega n d omega. Okay. These are the basic DTFT and IDFT formula. Integral over any one time period. Okay, that is the integral over any one time period could mean, this integral over any one time period could mean that integration from 0 to 2 pi, or commonly from minus pi to pi, or any limit of integration which covers the one time period. Any limit of integration which covers the one time period. Right. So it can be any one of them, 0 to 2 pi or minus pi to pi. The 0 to 2 pi or the minus pi to pi. Okay. Chalo, cool. The 0 to 2 pi or the minus pi to pi. Now guys, some more important properties that you can relate from here. Also guys, note that DTFT is always a periodic function. That is why while recovering the signal, while using the IDTFT formula, we take the information for only one time period. DTFT is always periodic with the period of 2 pi. That is x of omega plus 2 pi is equal to the x of omega. The x of omega plus 2 pi is always equal to the x of omega. Acha, noting down this formula, there are some important techniques to remember. So suppose if you want to calculate the x of 0, that is what actually is the first question. Then x of pi, that is the mid value. Okay, so when you want to calculate the x of 0, please note down some important results from here. Number 1, x of 0 is a summation of the series. What is the x of 0? If I put omega equal to 0, e power 0 is 1. That turns out to be summation of xn. for all values of n. That is number one important result, right? The value of the DTFT at half the time period. At half the time period. So when you put omega equal to pi, it becomes e power j pi n. And what should be the value of e power j pi? Let me just give you the final result, guys. So e power minus j pi will be 1. E power minus j pi will be minus 1, I mean. So minus 1 raised to the power n will come. Minus 1 raised to the power n will come. So x of pi will be given by minus 1 raised to the power n multiplied by xn. Okay, that means if the first property is, if you start from 0, see, actually you can start from minus infinity to infinity. So let's say I take from 0, so it will be x0 plus x1 plus x2 plus x3, summation of all samples actually, right? But in the second case, you have summation of, no, Ruby, they are not same. They are not same. DFT is the Fourier transform itself, which is discrete. That means the frequency also in the discrete transform, DFT is the discrete. In the DTFT, omega is a continuous variable. Omega is a continuous variable. In the DFT, we discretize the frequency first of all, and then we get the DFT. Okay, so this is like if you start from x of 0, minus 1 power 0 is 1, or minus 1 power 0 is 1. Minus 1 power 1 will be negative, so you have minus of x1. Minus 1 square, then positive, so plus of x2. Minus of x3. So alternate plus minus pattern has to be followed. Alternate plus minus pattern has to be followed, right? Some more important points to note from here. The area under the curve. So now if you take n equal to 0 in the IDFT formula, number third point to be noted here is, let me write down here only. Number third point to be noted, put down the n equal to 0. You get x0 as 1 upon 2 pi integral x omega d omega, or vice versa. Integral x omega d omega, integral of x omega d omega over one time period is equal to 2 pi. So 2 pi I can shift on the other side. 2 pi xn and n ki value 0. So 2 pi x0. 2 pi x0. Good evening, Chandra. Right. Not only this much, guys. Not only this much. Integral x omega d omega is 2 pi x0. But here, if you want to put any special value of n also. If you want to put any special value of n. Suppose you want to put n equal to n naught. Let's put any specific value. And there will be the fourth result. So integral x omega d omega over any one time period multiplied by e power j omega n naught, right? Multiplied by e power j omega n naught. So if I put n equal to n naught, this will become x of n naught whole multiplied by 2 pi. This is 2 pi x of n naught. These are some common results where questions are expected. Good evening, Gokul. Some common areas where the question can be expected. Okay. So keep those in mind. Keep those in mind, right? Chalo, now one by one, we'll see if anything else is required. One by one, x of 0. So x of 0, as I told you, it is summation of xn. Chalo, to yahan pe aa jate hain. So first part, guys, the first part, x of 0, as I've already explained you, it is given as summation of xn. So just add up all the values. Now this value, don't add the time, add the value. This value is minus 1. Plus the value is 0, then the next value is plus 1. Plus 1 ke baad you have 2. Ocha, this is missing. Okay, I'll just sketch this. Okay, this is 2. This line is missing. Okay, this line was missing. Let me draw in the actual diagram also. This dot clearly tells ki value 2 hona hai, but the line went missing. Okay, line went missing. Okay, so the next value that I have obtained, just a second. That I've obtained is plus 2, right? Then I have 1, then I have 0, then I have 1, then 2, then 1, and after 1, 0, and then finally minus 1, a 0 and then a minus 1. Let's look at the final value. Minus 1, 1 cancel here, minus 1, 1 cancel here also. So 2 plus 1 plus 1, that is equal to 4 plus 2. Check it out, the answer, is it coming to be 6? Good evening, Dreamer. Just check out the answer, guys, whether that is equal to 6. Just check up the calculation. Okay. Now, when I come to the second part was x of pi. Calculate the value of x pi. Okay, so here it is the second part of the question. Calculate the value of x pi, and as I told you guys, x pi is summation minus 1 power n xn, right? With alternate plus minus. So what is the first value you are starting? First value, look at this, is minus 1, but the value of time is an odd value. The value of time is an odd value. The value of time here is the odd value. Okay. So the first value that is going to come for you is minus of minus 1. Why this minus is coming? Because this is minus 1 raised to the power minus 3 and 3 is an odd number. Okay, so the first value negative and you don't have to take minus 1 power n every time. Take alternate. If the first one is with minus, next will be plus, next will be minus, etc. So next will be plus of 0. Sir, value is absent. Next will be minus of 1. Next will be plus of. As I told you, this is 2. This is 2. Next will be plus of 2. Right. Then next will be minus of 1. Plus of 0. Minus of 1. Plus of 2 again. Then minus of 1. Plus of 0. Minus of minus 1. Now check out the total value. This becomes 1. 1 minus 1 cancel. 2 minus 1 minus 1 yahan tak bhi cancel. 2 minus 1 plus 1. So the answer should be equal to 2. Just check out the calculations and just keep confirming me. The final answer is also equal to 2. The final answer is equal to the 2. The final answer is equal to the 2. Okay. Okay guys, so what is the third part of the question? The third part of the question is calculate integral x pi x omega d omega and then x omega e power j omega n naught. Okay, let us calculate the third and fourth now. Let us now calculate the third and fourth. So third is integral minus pi to pi. Minus pi to pi means one time period. So integral x omega d omega for one time period, already I explained you, is equal to 2 pi x0. So this is a very simple question. 2 pi x0. What is the value of x0? It is equal to 2. So the answer is 4 pi. This value, this is equal to 2. Okay. This value which is equal to the 2. Next question guys, moving to the fourth one. This one was very simple. Ye ho gaya third. Fourth one again integral over one time period x of omega e raised to the power j 2 omega d omega e raised to the power j omega n naught e raised to the power j omega n naught is given by the value 2 pi x of n naught. What is the value of time coming? 2. So this is also a simple question. 2 pi x2. What is the value? What is the value of the signal at 2? This is the value required. Okay, and the value is 0. So the final answer is 0. Fourth part is also simple. Now sir, let us come to the fifth part, and fifth part is related to the Parseval's theorem. The fifth part is related with the Parseval's theorem. Okay, the fifth part is related with the Parseval's theorem. So let us go and solve the fifth part as well. Here it is, the fifth part. Okay, fifth part ke liye first let me take, what is the fifth part? Let me write down the question once. And the fifth part is asking integral minus pi to pi integral over one time period modulus of x omega square d omega, right? And for that let us just go to the Parseval's theorem. So guys, through these questions we are going to cover up the different properties, all types of different properties required for DTFT, so you can feel confident in the DTFT with these questions also, right? So what is the Parseval's theorem? The Parseval's theorem says that the energy of signal in the time domain is summation mod xn square for all values of n. But that energy, this is the time domain formula, but that same energy can be calculated in the frequency domain as 1 upon 2 pi integral minus pi to pi, once again integral over any one time period, integral 2 pi modulus of x omega square d omega, modulus of x omega square d omega, right? Right. Now, Ashok, we are doing the questions of DTFT, 11 most expected questions. Through that questions, I am making the properties also revised. All properties also coming up through questions. So, questions will also be covered, practice will also be done, and properties are going to come in front of you. Need not worry. Okay. So, this is the energy formula, and now this becomes, so question is question pe aa jate hain. So, now this question becomes integral x omega square d omega, that should be equal to 2 pi. According to the Parseval's theorem, 2 pi summation mod xn square, right? Complete this calculation. So this will be equal to 2 pi summation mod xn square. So even all negatives will be converted to positive. So minus 1 ka square 1, then 0 square, then 1 square is 1, then you have 2 square which is 4, 1 square 1, next is 0, again 1 square is 1, again 2 square which is 4, again 1 square is 1, and last mein minus 1 square which is again 1. They're very soft in the calculation. So 1, 1, then 6, then 7, 8, 9, 10 and 14. 14 2s are 28. Just check and match your calculation. Answer should be 28 pi. Answer should be the 28 pi. This part itself is done. Okay. So this is the question number 2 done. This is what is the question number 1 actually, covering up 5 parts. The question number 1 itself has covered up the 5 parts, and now let's move ahead to the next question ready for you here. The Fourier transform of x to n. Now guys, if it is a continuous time signal, we have the time scaling property of DTFT. But in the discrete signal, the time scaling property is not always perfect, because when you specially do the compression of the signal, so what is x to n? X to n represents the compression of the signal, and we all know that whenever we compress a discrete time signal, the samples are lost. The samples are lost, right? What is actually x to n? What will be x to n? So this is origin, n equal to 0. Right, so compression x to n, all values of time divided by 2, right? So this is -1, -2, 1, 2, 3. So whatever is the value at -2 will go to the -1. This will be -1 time. Then the value at -1, listen to me, the value at -1 should go to -1 by 2. Should go to -1 by 2. But in discrete time domain, there is no -1 by 2. You cannot take the time as you cannot take the time which is non-integer, So we cannot take this time. So we have to skip this value. That is why the samples are lost. Then 0 divided by 0 is 0 only. So the next sample will be at origin 3 as it is. 1 divided by 2 is 1 by 2. Non-integer, not allowed. 2 divided by 2 is 1. So next value of time is 1, and the value of the signal is also 1 there. 3 divided by 2 are not integer. 3 divided by 2 is not integer. Right? So you cannot take this value. So signal ends. So that is what I told you. Some samples of the signals are lost during the compression period. During what? During the compression period. This is x to n. So that is why in this case we directly evaluate. Okay. Ashok, primarily for energy calculation only. For those signals whose energy in time domain is very typical or complicated. But yeah, let's wait at the end. Let me first cover the 11 questions. If time is left, I'll elaborate more on that, Ashok. But first, let us go through the 11 questions. So the signal is just 131. Okay, so what is the DTFT of the signal? What is the DTFT? So let this signal be yn. Right, so the DTFT y omega. Let's apply the regular formula, na? Summation y of n e raised to the power minus j omega n. Right, so what is the first value of yn is 1, and the value of time is -1. So 1 into e power minus j omega minus 1. Next value of the y is 3, e power minus j omega into 0. Next value is 1, e power minus j omega into 1. Right, so this is e power minus plus. So this is e raised to the power j omega plus 3 plus e raised to the power minus j omega. You can club these two. E power j theta plus e power minus j theta is 2 cos theta. So the answer is 3 plus 2 cos theta. 3 plus 2 cos omega. The answer should be the 3 plus 2 cos omega, option number B. It should be the 3 plus 2 cos omega. That is the answer number B. Answer number B. It should be the 3. Okay guys. Next question going ahead. Welcome Vedant to the session. Question third ready for you. A Fourier transform pair is given to you. 2 by 3 power n u n plus 3 is a e power minus j 6 pi f. In the f domain it is given upon 1 minus 2 by 3 e power minus j 2 pi f, where un is the unit step sequence. What should be the value of a? So it is based on the basic time shifting. Basic time shifting. Two things to note here. A raised to the power n un DTFT. What is the a raised to the power n un DTFT pair? It is given by 1 upon 1 minus a e power minus j omega if mod a less than 1. The DTFT converges only if the mod a less than 1. Right? Please recall two important things. Two important things about the DTFT. About the DTFT. Okay, then next is if xn is having the DTFT x omega, right, what should be the DTFT of x of n minus n naught? So whenever there is time shift, there is a phase term, there is a phase change in the frequency domain, and that becomes e power minus j omega n naught. That becomes e raised to the power minus j omega n naught. So these are the two important points to recall to consider these two questions, this particular question. So now you have 2 by 3 power n un plus 3. Un plus 3 will take to time shifting, but think 2 by 3 power n. That means yes, a is less than 1. Modulus of a is less than 1. So we can think about applying the formula. But let us first start with the formula for 2 by 3 power n un. Let us start with un without the shifting, and the DTFT for this will be 1 upon 1 minus 2 by 3 e power minus j omega, because modulus of a is less than 1. Modulus of a is less than 1. Now if I do the time shifting, but if I have to do the time shifting now, so I cannot only write un plus 3. If time shifting, everywhere you have to write n as n plus 3 everywhere. So here also 2 by 3 power n plus 3, u of n plus 3 will have the DTFT. Now in the time shifting, what will happen? The DTFT 1 upon 1 minus 2 by 3 e power minus j omega is multiplied by e raised to the power j 3 omega, e power j omega n naught, n plus 3, so e power plus j 3 omega. Okay, now separate the term 2 by 3 power n, 2 by 3 power 3, 2 by 3 power n, 2 by 3 power 3, इनको separate कर दिया, into u of n plus 3. This should have the DTFT. E raised to the power j 3 omega. Omega is 2 pi f, so e power j 6 pi f upon 1 minus 2 by 3 e raised to the power minus j 2 pi f. So I think there is a typo error in the question. ये भी plus होगा guys. Okay, the typo error, it has to be plus 100%. It has to be plus. Now we are very close getting the value of a. So what should be 2 by 3? It is a constant at 2 by 3 power 3. Send it on the right hand side directly. Right. It is a constant 2 by 3. When you send on the right hand side, it will become the 3 by 2. Right. So you have 3 by 2 raised to the power 3. Now this is what is the value of a. Rest all everything is given in the question. A e power j 6 pi f upon 1 minus 2 by 3 e power minus j 2 pi f. So this extra factor, that is what is the value of a. That is 3 by 2 whole cube. Numerical answer type question. So 3 cube is 27, then divided by 8, that is 3.375. The answer should be the 3.375. The answer should be the 3.375. The answer should be equal to the 3.375. 3.375. All cool. Okay guys, so this is done. Let's go to the next question. Okay, now let us understand this question, little bit related with the DTFT and convolution. A signal input xn with length 3 applied to a LTI system having impulse response hn of length 5. Y omega is the DTFT of the output yn. Okay, DTFT of the output yn. So how do you calculate output of any LTI system? How do you calculate the output of any LTI system? इसको यहाँ लिखते हैं. How do you determine the output of any LTI system? It is the input xn convolution with the impulse response hn. So what should be the DTFT? The DTFT y omega is x omega into h omega. If there is convolution in the time domain, there is multiplication in the frequency domain. So x omega, h omega. Y omega is the DTFT of the output. What is the maximum value of y0? Right. So what is y0 first of all? What is y0? It is given by the property summation of yn. Question number 1 for today. Question number 1, part number 1. 1.1 question you can say. So what is y0? It is summation of yn. Okay, summation of yn. Now use the convolution property. Right. Use the convolution property. Discrete time में summation. Continuous time it is integral. What is the, if it is discrete time, the area of yt is the product of area of xt and ht. That is integral yt is integral xt into integral ht. But in the case of discrete time, it is known as summation. So summation of yn is summation of xn, summation of all values of xn multiplied by summation of all values of hn. That is what is summation yn. Summation xn into summation of hn. Okay, and that should be the value of y0. तो y0 तो ऊपर लिखा ही हुआ है. So this is what is one of the convolution property that we are going to use. Now what should be the maximum value of y0? देखो अब यहाँ से ध्यान रखना. We need the maximum value. hn is less than equal to n for all values of n. The modulus of hn is less than equal to L for all values of n. Right? लिखा है ना? This is the symbol for all values of n. That means the maximum value of hn is L. Right? The maximum value of hn is L and the maximum value of xn is equal to the b. xn is equal to the b. Now you want the maximum value. Where is that gone? You want the maximum value of y0. Right? You want the maximum value of y0. Understand the logic. It means you want the maximum value of summation yn. This can be maximized if you individually maximize. Now, how can you maximize all the values of xn? You want the summation of xn to be maximum. That can be maximum if all the individual values are maximum. And what is the maximum value of xn? What is the maximum value of xn? B. So all values, if you take b, how many times check karte hain? Similarly, to maximize summation hn, all values of hn should be maximum. Maximum value of hn is L. So L plus L, how many times? तो अब देखोगे ना, hn का length है 5, so it has 5 samples. Length of xn is 3, it has only 3 samples. So this is only 3 times. This is only 3 times. Now let me do the correction. B will only come 3 times. L will come 5 times. Right? So this is equal to 3b into 5l. 15 times LB will be the answer. 3 into 5, 15 times LB will be the answer. A very good question relating one simple DTFT property. The DTFT property is only very simple. Y0 summation yn. Rest you should know about the convolution and then a very simple logic of maths. We want to maximize summation xn and summation hn. ठीक है? So a good question, combination of different properties. A good question of the combination of different properties. Question number 5 now, because it is a question that you can attempt, let me give you this question as homework. I'll tell you the hint to solve this question. It's a GATE 2-mark question. So let me give you the hint to solve this question. The hint to solve this question is, you have sine squared 2 omega, na? You can break the sine squared 2 omega. You can break the sine squared 2 omega. How you can break the sine squared 2 omega? See, either by the trigonometric identity or by the Euler's rule. What is sine 2 theta? E raised to the power j 2 omega plus e raised to the power minus j 2 omega. Sorry, minus aayega beech mein. I am writing about sine na. E power j theta minus e power minus j theta divided by 2j and take the square. Now once you break this na, okay, you are going to get x omega multiplied by some e power j 4 omega suppose. First term will be e power j 4 omega after getting the square. Okay, so there will be different terms. So what you have to use then, after this, you have to use that integral of x omega e power j omega n naught. Again related with the question number 1 part 2. Today's class only question number 1 part number 2. This was equal to 2 pi x of n naught. This was equal to 2 pi x of n naught. Xn is given to you. 2 pi x of n naught. Okay. So there will be actually 3 different terms coming up. A square plus b square plus 2ab. Okay. Then simplify. This is the hint to solve the question. Right. This is what is a small hint to solve the question. Please attempt this question. It's a good question to attempt. Please attempt this question. Let's then be ready for the next question. Number 6. A GATE 21 2-mark question. Let us discuss. Consider the signals xn and yn given to you. Let x e power j omega, y e power j omega be the DTFT of x and yn. What is the value of the integral 1 upon 2 pi integral 0 se 2 pi x omega y e power minus j omega d omega? Dhyan dena. Right, very crucial properties will be used here. It's a good question for 2 mark, GATE 21. 1 upon 2 pi integral 0 se 2 pi x of omega, let us write our regular language, x of omega, y of minus omega, d omega. That is the question. So let us first say, okay, let us first say there is a function z omega which is equal to x of omega, y of minus omega. So two DTFTs are multiplied, sir. Two Fourier transforms are multiplied when there is convolution in the time domain. When there is convolution in the time domain. Okay, so when you see in the time domain, the signal Zn should be the convolution of Xn with Yn. No, Yn nahi hoga, because if it was Yn, this should be Y omega. So whose Fourier transform is Y minus omega? Y minus n. Simple time reversal property. Simple time reversal property. Y minus n has the DTFT Y minus omega. Time reversal property applicable for DTFT and CTFT both. It is applicable for the both DTFT and CTFT. So Z of n is Xn convolution Y minus n. Xn convolution Y minus n, right? But you don't want the Zn. Now the question is 1 upon 2 pi integral over one time period 0 se 2 pi x omega y minus omega is z omega. Okay. Integral z omega d omega. Integral z omega d omega was 2 pi z0, 2 pi cancel, it is simply equal to z0, small z0. So you want the value of the convolution only at n equal to 0. You want the value of the convolution only at n equal to 0. Acha, what is xn and yn? Now time to write that. What is the xn? 2 raised to the power n minus 1 u of minus n plus 2. U of minus n plus 2. What is the yn? 2 raised to the power minus n plus 2. 2 raised to the power minus n plus 2 u of n plus 1. U of n plus 1. Right? U of n plus 1. That is what is the yn also given to you. Okay. We need actually y minus n. So this will be 2 raised to the power, replacing n by minus n, 2 raised to the power n plus 2, n की जगह minus n होगा केवल, u of minus n plus 1. U of minus n plus 1. Okay. So let's say this is equal to hn. Okay. So Zn is xn convolution hn, convolution y minus n को hn बोला है, and the formula for convolution, basic convolution is summation of xk h of n minus k. H of n minus k. अब देखना twist देखना story में, right? So I want only the value of z0. I only want the value of z0, right? So z0 will be equal to summation of xk. Eventually when you put n equal to 0, you get h of minus k. But h of minus k kiya वापस, तो that will be y of k. So question is summation xk yk. You have to find summation xk yk. The question is summation xk yk. The summation xk yk. Now this is equal to summation xk 2 raised to the power n minus 1 u of minus n plus 2. 2 raised to the power k के form में लिखेंगे, I'm sorry. So this is a good property based and even involving some calculations. So 2 raised to the power k minus 1 u of minus k plus 2 is multiplied by yk, that is 2 raised to the power minus k plus 2 is multiplied by u of k plus 1. Now ध्यान देना, this is for all values of k, but the unit step is going to modify your limits, right? Minus k plus 2, for unit step existence, minus k plus 2 should be greater than equal to 0, so k should be less than equal to 2. Here k plus 1 should be greater than equal to 0, so k should be greater than equal to minus 1, right? Unit step equal to 1 if the argument is positive, greater than equal to 0. So this summation actually becomes, like, k should be greater than minus 1 but less than 2, so k should be minus 1 to 2. Greater than equal to minus 1, less than equal to 2. 2 raised to the power k, 2 raised to the power minus k cancelled. क्या बचेगा? 2 power minus 1, 2 power minus 1, 2 power 2. It is total 2 power 1. That's it. So your answer is now ready. Right? 2 power 1 is a constant, that is outside. Summation of 1. 1 is just equal to 1. But how many times? Minus 1, 0, 1, 2. How many samples are coming? Count from minus 1. Minus 1, 0, 1, 2. -1, 0, 1, 2, total 4 values are coming. या आप ऐसा बोल सकते हो कि the function inside the summation is 2, so it is a constant 2, but that has to be counted how many times? Function is constant 2, but it has to be counted 4 times, so the answer should be equal to the 8. Check out your answers and let me know for any doubts. Your answer has to be 8. Your answer has to be 8. Okay. Okay, sir. Chalo. So let's move ahead. Let's move ahead to the next question. Number 7 ready for you. A system with the transfer function hz has the impulse response. IR means impulse response. Okay. That is defined as h2 is equal to 1, h3 is equal to -1 and hk equal to 0 otherwise, and consider the following statements. Right, hz is a low pass filter, hz is a FIR filter. Right, see from this information, h of 2 is 1, h of 3 is -1. Only 2 non-zero values are there. Only 2 non-zero values are there. Only 2 non-zero values are there. So what to do? Only 2 non-zero values are there. Okay, only 2 non-zero values are there. That is at n equal to 2, n equal to 3. So origin pe there is nothing. Then you have n equal to 1, then n equal to 2 pe 1 hai, and then -1. And this should be the case, and this is the origin. N equal to 0, then n equal to 1, nothing. N equal to 2, n equal to 3. Okay. So there is an impulse response. There is an impulse response whose length is equal to 4, which is finite. And whenever the impulse response is finite in nature, very basic definition you should know. Whenever the impulse response is finite in nature, such a filter is a FIR filter, finite impulse response. FIR is for finite impulse response. The length is 4, you have a finite impulse response. So statement number 2 is very correct. But whether it is a LPF, LPF means low pass filter. So when it is a discrete filter, see, analog mein things are different. When it is a discrete filter, what is the low frequency you take? The low frequency is omega equal to 0. What is the high frequency you take? High frequency is omega equal to pi, because the entire spectrum of DTFT is commonly taken from -pi to pi, one time period. -pi to pi, pi is the highest frequency, high frequency we consider. And then we have a mid frequency, or also known as intermediate frequency. And any mid frequency actually you can consider, but we just take it as the middle point exactly, that is pi by 2. That is pi by 2. Okay, this is what you should remember. And now what is HN? Dhyan denge. What is the HN? 0, 0, 1, -1. Let us write down the HN once again. 0, 0, 1, -1. So what is H of omega? What is its DTFT? Okay, summation, apply the same formula. Summation of the HN e raised to the power minus j omega n. It is summation of the HN e raised to the power minus j omega n. Okay, so first value is 0. Okay, then 0, then I have 1 into e raised to the power minus j omega into 2. यहाँ पे n का value 2 है. Right, then you again have -1 multiplied by e power minus j omega into 3. Right, so what is the h omega eventually? E power minus j2 omega minus e raised to the power minus j3 omega. E power minus j2 omega minus e power minus j3 omega. Right, let me write down once again. What is h omega? E raised to the power minus j2 omega minus e raised to the power minus j3 omega. So when I have to check at the low frequency, what is h of 0? E power 0, 1, e power 0, 1. So low frequency result is 0. So definitely it cannot be low pass filter. Definitely it cannot be a low pass filter, because if it was a low pass filter, it will pass the low frequency with high gain. But it is blocking the low frequency. It does not pass because it has 0 gain. Okay, so we will continue the discussion, but at least one point is clear. Whether it is a low pass filter, no. Right, so which of the statement? Only statement 2 is correct. Option number A should be the answer. This question is finished, but let us continue. If it is not a low pass filter, what it is? If it is not a low pass filter, what it is? Can we decide? Yes sir, easily we can decide. Easily we shall be able to decide. Right, first let's go with the mid frequency also. Let's go in the sequence. Yeah, h pi, first go with the high frequency only. the regular trend that we follow, no issues. So omega equal to pi e raised to the power minus j2 pi e raised to the power minus j3 pi. देखो हमेशा याद रखना e raised to the power, please listen to me, e raised to the power minus jn pi, because this is a very repetitive calculation. E power minus jn pi will be always equal to 1 if n is even. It will be equal to minus 1 if n is equal to odd. Sir, why? Why? Arey, open up the Euler's identity na, cos theta plus j sin theta, you will understand. Karke dekh lena, you try yourself, right? Cos theta plus j sin theta, you open, you will get that trend. So this is e power minus j2 pi, n is equal to 2. Here n is equal to odd, so answer will be minus 1. So 1 minus minus 1, it is 2. Definitely it is passing the high frequency with the gain 2. Considerable gain, so it can be a high pass filter. And just to show you the waveform, just to confirm you the pattern, let me also show you the mid frequency value. When I take the pi by 2, I get e power minus j pi first of all, then minus e raised to the power minus j3, omega ki jagah pi by 2, so 3 pi by 2. E power minus j pi, already I told you that is going to be minus 1. E power minus j3 pi by 2, sir, that is cos 3 pi by 2, cos 3 pi by 2, that is 0, right? Minus j sin 3 pi by 2 and sin 3 pi by 2, sin 270 degrees minus 1. So total ye ho gaya minus minus plus. So this is minus 1 minus j. Minus 1 minus j. Now if I want to show you the sketch of its spectrum, yahin pe show karna padega. I don't have much of the space available. Okay, so if I want to show you the sketch of the spectrum, modulus of h omega as a function of omega, modulus of h omega as a function of omega, right? Let's show for 0 to pi, let's show for positive frequency only, right? At the pi, the gain is equal to 2, that we all know. The gain has been calculated at 2. This is equal to pi, okay? And the gain is, this is minus 1 minus j. So when you take the magnitude, na, square root of 1 square plus 1 square, that will be root 2, right? So at the mid frequency, that is pi by 2, the gain is equal to root 2. The gain is equal, the gain is root 2. So when I draw this plot, na, it's approximately showing a trend something of this kind. It is showing a trend of this kind. So what is this? It is showing a trend of this kind, and that is what basically is a high pass filter, which has high gain towards high frequency. It is passing the high frequencies with higher gain, and it is passing the low frequencies with a considerable low gain, which is said to be attenuating gain. The gain will be less than 1 near low frequency region. Less than 1 gain means it is going to be attenuated. So that is what is basically the high pass filter. So what is the answer? It's a high pass filter. Already we concluded the question. It is not low pass filter, but what actually it is a high pass filter. It is a high pass filter, right? If you are able to understand the concepts, do not forget to like the session. So one more example of such kind, let me give you as a homework as well. One more question of the kind, let me give you as homework as well, right? Homework, and if you are able to understand the concept, do not forget to like the session. I just tell you, this is question number 8 as homework. This given filter is approximation of what? Chalo, one more of similar kind, let's solve this one. It's a GATE 2 mark question, as you are able to see that. This question is a GATE 2 mark question as well. This question is a GATE 2 marks question as well. So just to give you a feel that simple questions are also there in the GATE. Okay, so what is this? Whether it is low pass, high pass, band pass or band stop. Okay, so first I have to get the DTFT for this. Right, the direct form structure of FIR filter is shown to you. Okay, this is the 9th question. Yeah, so first I have to derive the relation. So what is this yn, guys? What is this yn? So first the input xn is there. Let's convert them into a unit. See, into unit delay also. So if this is unit delay, what should be here? X of n minus 1. One more unit delay. Delay means right shift. So this will be x of n minus 2. Right. This is simply the gain 5. So this is 5xn. So now what is the output yn? Output yn is input 5xn minus, here also 5 again is multiplied, but 5 is multiplied by xn minus 2. तो यहाँ पे आ गया 5xn minus 2. 5xn minus 2. With this IO relation, we can calculate the frequency response of the system. Okay, we can calculate the frequency response of the system. Let's do it up quickly. So what is the yn? It is equal to 5. Let's take the 5 common. Then you are left with xn minus 2, correct? You have the xn minus 2. So what should be the y of omega? Converting into the DTFT, so xn has the DTFT x of omega minus time shift property x of omega, n minus 2 है तो e power minus j2 omega, phase term. Okay. So what is the frequency response of the system? How do you define the frequency response of the system? The frequency response h of omega is defined as y of omega divided by the x of omega, and when you divide the x omega on the left hand side, you get 5 1 minus e power minus j2 omega, 5 into 1 minus e power minus j2 omega. And now what is the low frequency and high frequency result? Omega equal to 0. What is h0? What is the h0? Right, it is equal to 5 1 minus e power 0. E power 0 is 1. So low frequency result is 0. Definitely it is not a low pass filter. Definitely not a low pass filter. Omega equal to pi. H of pi 5 1 minus e power, omega की जगह pi, तो e power minus j2 pi, right, which is equal to e power j2 pi, even power, n का value even, so this is also 1, so 1 minus 1 is 0. Oh my god, the gain at the high frequency is also 0. So it is neither a low pass, it is neither a high pass. It is neither a low pass nor a high pass. So what it is? What type of filter it is? Let me check the omega equal to pi by 2 as well. So you have h of pi by 2, which is equal to 5, which is equal to the 5, 1 minus e raised to the power minus j pi. Omega I have substituted as pi by 2, so 2 and 2 cancel. E power minus j pi, odd value of n. So the result will be minus 1. 1 minus minus 1, 2. 2 into 5, 10. So if you want to plot this, how the results are going to look, have a look into this. This is omega, and let's plot the magnitude spectrum modulus of h omega, again considering the 0 frequency up to the highest pi frequency and the mid frequency, right? The gain at the mid frequency has turned out to be 10. So let's say this is the value 10. Let's say this is the value 10, but the gain at the low frequency was 0. The gain at the high frequency was equal to 0, but the gain at mid frequency is 10. So that means what can be the expected pattern? So the magnitude will be rising. It reaches its maximum at pi by 2, and then it is again falling, and it's becoming 0 at the high frequency. It is neither low pass nor high pass. It is neither the low pass nor the high pass. It's a type of band pass filter. It's a type of band pass filter which passes a band of frequency from some frequency omega 1 up to the omega 2. By the 3 dB concept, we can also calculate omega 1 and omega 2, but right now we just need to comment. Okay. Okay, so by the 3 dB concept, we can also calculate what is omega 1 and omega 2, right? Okay, so 3 dB concept, okay, where the magnitude is 1 by root 2 times the maximum magnitude, right? What is the maximum magnitude? 10. So 1 by root 2 of 10, 5 root 2. So you can equate this given function. Okay, you can equate ki whenever the magnitude of this is equal to 5 root 2, okay, those set of frequencies, solving that you will get omega 1 and omega 2. Right, and the band gap will be known as the bandwidth, right? So it's a band pass filter between omega 1, omega 2. Omega 1 and omega 2, you can concept, I'm just giving you a hint, you can calculate by the 3 decibel concept, 3 dB bandwidth concept. But right now the question is completed. Question number 10 ready for you. Design a 3-point FIR filter with the impulse response Hn equal to alpha beta alpha and the amplitude response blocks the frequency 1/3 and passes the frequency 1/8 with unit gain. What is the DC gain of the filter? What is the DC gain? It's all questions based on application of DTFT. It's not like designing properly that FIR IIR cases. It's a logical question. It's a logical question. Don't rely that whether you have to study FIR IR. Even if I remove FIR IIR, it can be a normal system. Design a system whose impulse response Hn is given to you, right? And the amplitude response blocks the frequency 1/3, passes the frequency 1/8, okay, with unit gain. What is the DC gain of the system? So you can also say like this: design a system. It's a pure DTFT question, so don't just think that whether this FIR question can come or not. It's a system based question, a logical application based question. Design a system with the impulse response, right? And also find the DC gain of the system. Also find the DC gain of the system. Ab is question ko kar lete hain so that there is no doubts in your mind. Okay, so the impulse response is given to you. See, FIR is just clear indication that the impulse response is finite. That anyways we are able to see. The length of the impulse response is 3. So anyways it is finite. So Hn is equal to the how much? Hn is equal to the alpha beta alpha with the central value at beta. Hn is equal to the alpha beta alpha. Alpha beta alpha. Hn is equal to the alpha beta alpha. So what is the H omega? What is the DTFT? So alpha e power minus j omega into -1 summation Hn e power minus j omega n plus beta e power minus j omega n ka value 0. Once again alpha e power minus j omega n ka value 1. N ka value 1. Right. So what is this equal to? Alpha e power minus plus e power j omega plus beta plus alpha e power minus j omega. Right. So h of omega is equal to alpha को common लेते हुए alpha common e power j theta plus e power minus j theta will become 2 cos theta. So that is 2 cos omega and plus beta. That is the h omega. That is h omega. Or h omega is 2 alpha cos omega plus beta. Now they say that it blocks the frequency 1/3. F is equal to 1/3. First of all, omega is equal to 2 pi f. That is 2 pi by 3. So this particular frequency is being blocked. So at this frequency, h of omega should be 0. Mod of h omega 0 and hence h omega equal to 0. So that is 2 alpha cos of 2 pi by 3 plus beta should be 0. 2 alpha cos 120 degree is -1/2 plus beta equal to 0. So 2 to cancel, minus alpha plus beta is 0. So here you get the relation alpha equal to the beta. Here you are able to get the relation, that is the alpha equal to beta. Right. Now f is equal to 1/8 is passed with unit gain. F equal to 1/8. So omega is equal to 2 pi f, 2 pi by 8 or pi by 4. At this frequency, the gain h pi by 4, mod h omega will be h omega because it is a real function. So h pi by 4 should be equal to unity gain. It should be unity gain. So 2 alpha cos omega, 2 alpha cos omega, that is cos of pi by 4 plus beta is equal to 1. Cos pi by 4 is 1/√2. Right. So √2 cancel. You have √2 alpha plus beta is equal to 1. But you can put down beta is equal to alpha. So everything in the form of alpha. √2 alpha plus alpha equal to 1. So alpha will be 1 divided by 1 plus √2. Let us calculate this value actually. So this is 1 divided by 1 divided 1 plus √2. So what is this value equal to? Okay, so this is approximately 0.414. This is approximately equal to the 0.414, right? Okay, so what is the DC gain of this filter? Alpha beta to dono aa gaya. What is the DC gain of the filter? DC gain means zero frequency gain. So final question is find the DC gain. Okay, that means the gain at zero frequency. What should be the gain at zero frequency? 2 alpha cos omega plus beta and omega का value 0 रखेंगे, right? So 2 alpha cos 0 plus beta, cos 0 is 1, so the DC gain of the filter should be 2 alpha plus beta, that is 2 alpha plus alpha, because beta is alpha, so the answer should be 3 alpha, so 3 into 0.414, okay, 3 into 0.414, so 1.242. The DC gain is 1.242. Hi Shubhadip, Pranam. 1.242, right? Yes, it's a nice question, Ashok. It's actually a nice question. Okay. So this is what is done. What is the DC gain? This is the main numerical type question that is also completed. This is also completed. And the last one, question number 11, now ready for you to be solved as a homework. Okay, so if Hn is the impulse response of ideal low pass filter with the cutoff frequency omega, what type of filter has the impulse response as -1 power n Hn? That's again a logical question. It is once again a logical question. Acha, for here you have to use a property. For here you have to use a property. Property मैं आपको hint करता हूँ. Property I will hint. Okay, so frequency shift property. Xn has the DTFT x omega, e raised to the power j omega naught n xn has the DTFT x of omega, has the DTFT x of omega minus omega naught, has the DTFT x of omega minus omega naught. Ab when I put omega naught equal to pi, right, so e power j pi n, e power j pi minus 1 होगा ना, so e power j pi n minus 1 power n xn has the DTFT x of omega minus pi, x of omega minus pi. Now this is sufficient hint to take up the question. This is a sufficient hint to take up the question. Okay, so this question number 11th is for homework to you. So around 2 questions around I think I have given you as homework for today. Please do attempt these homework. Please do attempt these homeworks. I could see a little less crowd today, but nevertheless those who were live, we have taken 11 most expected questions here, and once again a quick reminder that this coming Sunday on 17 July at 12:30 p.m. on the Byjus exam prep, a free mega workshop for you, a free mega important workshop for you, right? This time to be taken by me. Just a second, guys. Okay, okay. Chalo guys, that's it for the session. So if you are liking the content, if you want more such content without any miss, do not forget to subscribe the Byjus Exam Prep GATE YouTube English channel where you are watching this session, right? The same channel where you're watching this session, so that you get all such sessions of all technical as well, of all branches, mathematics sessions, aptitude sessions, generic sessions, and many others, right? Where, Satish? Where, in which platform you're talking about the EMF syllabus? Where Satish, answer me quickly so that I can send the complete the session. Your YouTube, I have taken some sessions of EMF. You can find that on the channel, and I'll be taking some more sessions of the EMFT, right, on the YouTube. right? If you're talking on YouTube. Okay guys, so bye bye, thank you, stay safe and take care. Hope you like these questions of DTFT.